In July 2024, NASA scientists watched the sky above Antarctica heat up by 15 degrees Celsius in a single week. Then, a month later, it happened again, 17 degrees this time. It was the earliest event of its kind ever recorded in 44 years of satellite data, and the people who study this for a living were, in their own words, genuinely surprised. And here's the part that should actually worry you more than the number itself. They still don't fully know why. That's not the only system acting like this right now. The Gulf Stream is wobbling. The jet stream looks like it's falling apart. And Earth's own magnetic North Pole is moving in a way nobody predicted. 4 completely different systems on 4 completely different parts of the planet, all behaving strangely at almost the same time. Here's the twist. By the end of this video, you're going to want the answer to be, yes, it's all connected. I'm going to tell you right now, it isn't. But the real answer is stranger and more interesting than a single unified doomsday cause. Stick around, because the honest version of this story is better than the scary headline version. 4 systems, 4 completely different mechanisms, 1 overlapping moment in time. Let's dig into the real science behind each one, and I'll flag it every time one story quietly nods at another. Keep an eye on this tracker in your head. Every time a system story actually touches another one, I'll point it out. By the end, you'll see exactly how many genuine links there are, and it's fewer than you'd think. Let's start with the one that keeps showing up in headlines threatening to plunge Europe into an ice age, the Gulf Stream, and the myth almost everyone gets wrong about it. Here's what the Gulf Stream actually is, and it's not quite what most people assume. The sun heats Earth unevenly, warming the tropics far more than the poles. Warm air rises, cools, sinks back down. That's the atmospheric circulation. Earth's rotation bends these circulation cells into what we call prevailing winds. And in the North Atlantic, those are the trade winds that carried Columbus toward America, and the westerlies that carried Spanish galleons home. Those same westerlies are why your flight from New York to London is shorter than the flight back. Wind-driven currents get forced into a rotating loop between the continents bordering the Atlantic, and Earth's rotation strengthens the western arm of that loop. That's the Gulf Stream, 50 to 150 kilometer wide, several hundred meters deep. Here's the detail that trips up almost everyone, including most news anchors. Look at an infrared satellite image of this current, and you'll notice something. It isn't off the coast of Europe. It's off the eastern coast of the United States. So why does everyone say the Gulf Stream keeps Britain and Norway habitable? Simple answer, because most people describing it have the geography slightly wrong. The Gulf Stream itself never reaches Europe. What reaches Europe is its extension, the North Atlantic Current. The Gulf Stream flows northeast along the US and Canadian coast, then merges with other Atlantic currents, including the Canary Current off West Africa, to become the North Atlantic Current. That distinction matters, because it means if the Gulf Stream stopped tomorrow, the North Atlantic Current wouldn't automatically collapse with it. It has other feeders. The truly big system both of these belong to is called the Atlantic Meridional Overturning Circulation, or AMOC, the one you've probably actually heard about without realizing it. AMOC moves warm tropical water north and pulls cold, salty water back south at depth, and it plays a massive role in regulating global climate. Here's the genuinely important distinction. The Gulf Stream is driven by Earth's rotation and wind. AMOC is driven by something completely different, thermohaline circulation. Warm, salty water travels north, cools, and because salt makes it denser, it sinks. That sinking pulls more water in behind it, driving the whole loop. This is the part climate change can actually touch. Arctic ice is fresh water. Melt enough of it into the North Atlantic, and you dilute the salty water that's supposed to sink, potentially slowing or stalling the whole conveyor belt. Whether and when that might happen is genuinely contested among climate scientists. Anyone giving you a confident date is stretching past the evidence. What we can say clearly, the Gulf Stream itself will not stop because of climate change. Because it's driven by Earth's rotation, and nothing about a warming planet is going to stop the Earth from spinning. If climate change stops anything here, it's AMOC, not the Gulf Stream. And here's a genuinely counterintuitive twist worth sitting with. Some researchers, including climate scientist Tim Palmer, have argued a slower AMOC could actually push the Gulf Stream's path further south, cooling northern Europe rather than simply devastating it, potentially even helping stabilize Greenland's ice loss. For anyone living in Europe, that's a mixed blessing at best, not a disaster movie. Even in a worst-case collapse, it could take thousands of years for AMOC to restart. And it's worth remembering, AMOC has collapsed and restarted multiple times across Earth's history through entirely natural cycles, long before humans were around to worry about it. Now from ocean to atmosphere. And a story that actually crosses paths with something you'll recognize from the news this year. This is the jet stream that couldn't sit still. A jet stream is a fast, narrow band of wind circling the planet, formed by temperature and pressure differences between the poles and the tropics. Hotter equator, colder poles, pressure zones form. Earth's rotation bends, the flow east-west via the Coriolis effect. That's your jet stream. There are two, the polar jet at high latitudes and the subtropical jet lower down. Meteorologists have described the jet stream over North America recently as unusually fragmented, breaking apart instead of flowing smoothly west to east. That waviness has driven blocking patterns behind genuinely severe heat waves, including events in parts of Mexico that reportedly approached 50 degrees C. So, what's actually behind this? Climate change is one real factor. As the poles warm faster than the tropics, that temperature contrast shrinks, and a weaker contrast means a weaker, more erratic jet stream. But here's the honest caveat most coverage skips. Climate change alone doesn't fully explain what's been happening. There's a faster, better understood culprit sharing the stage: El Niño. El Niño is a natural Pacific warming pattern that, despite starting as a regional event, reshapes pressure systems globally. It narrows the usual temperature gap between the eastern and western Pacific, which ripples straight into jet stream behavior, fragmenting it further, stalling high-pressure systems over some regions for weeks, and stalling low-pressure systems elsewhere. That's the recipe for both record heat waves and unexpected flooding, sometimes in the same season. According to NOAA, as warm water shifts along the equatorial Pacific during El Niño, the zone of peak evaporation shifts with it, and that has a measurable effect on the jet stream's average position. Given that, meteorologists identified a fresh El Niño phase following a preceding La Niña. The timing lines up. El Niño looks like the primary driver here, with climate change amplifying it rather than causing it outright. Quick gut check before we move on. Of these four, which one do you think turns out to be the most connected to the others? Drop your guess in the comments. I'll tell you if you're right at the end. This next one broke a 44-year record. The polar vortex. This one's sometimes described in Game of Thrones terms, an icy guardian normally locked behind an invisible wall. That wall is the polar night jet, a fast band of wind that keeps the polar vortex, a pool of extreme cold and low pressure, contained near the pole instead of spilling south. Sometimes the wall doesn't hold. When the polar night jet weakens or splits, cold air spills into lower latitudes. That's exactly what happened around Christmas 2022, when Arctic cold pushed as far south as Florida. Europe sits well within reach of the same effect. What weakens this jet? Not the Coriolis force. Earth's rotation isn't changing. It comes down to temperature contrast at the vortex boundary. Normally, the sharp clash between extreme polar cold and warmer outside air reinforces the jet stream wall. But factors like shifting sea surface temperatures, including El Niño again, and even solar activity can disrupt that balance, sometimes triggering a sudden stratospheric warming event where polar stratosphere temperatures can spike by up to 50 degrees C within days. This isn't new. The winter of 2009 to 2010 saw a record cold winter across parts of Europe from exactly this kind of disruption, with parts of Germany under continuous snow cover for 59 straight days. But there's real scientific reason to expect these disruptions more often going forward, somewhat ironically, because rising Arctic temperatures shrink the very temperature gradient that normally keeps the vortex stable. Now here's where it gets genuinely unprecedented. And this is the moment from the start of the video. There's a matching vortex over Antarctica, and in 2024, researchers recorded something that had never been seen there before. Normally, the Antarctic stratosphere sits around 80 degrees Celsius in winter. That's the sky that jumped by 15 degrees Celsius in a single week, the earliest sudden stratospheric warming ever recorded in that region's 44-year satellite record. Then, a month later, it spiked again, this time by 17 degrees. NASA atmospheric scientists Lawrence Coy and Paul Newman essay aid, in their own words, that they were genuinely surprised by both events. This kind of event happens over Antarctica roughly once every 5 years, versus almost annually in the Arctic, mostly because the northern hemisphere has far more land to disrupt airflow. The Antarctic vortex, which normally spins tight at roughly 300 km/h around the South Pole, stretched into a weakened, elongated, almost peanut-shaped pattern, and it had a real downstream effect. It delayed the formation of the ozone hole that normally starts forming in early August. A weaker vortex means less of the extreme cold, needed to drive ozone-depleting chemical reactions. So, briefly, this actually worked in the ozone layer's favor. Scientists were careful to note that a slow start doesn't mean faster overall recovery, since ozone health depends on a genuinely complex mix of chemistry and weather. What actually triggered it? NASA points to unusually warm Antarctic tropospheric conditions that July, the fifth warmest on record for the region, with sea surface and sea ice shifts likely playing a role. But there's also a real, not yet proven suspicion tying back to a single event 2 years earlier. The 2022 eruption of the underwater volcano Hunga Tonga, which sent an ash column an estimated 58 kilometer high, the highest ever observed from space, and injected an enormous amount of water vapor into the stratosphere. That water vapor can seed polar stratospheric clouds, which create ideal conditions for ozone-depleting reactions. It's a live, unresolved research thread, not a settled conclusion. Finally, the strangest and possibly most consequential story of all, Earth's magnetic North Pole, the pole that won't sit still. Quick but important distinction. The geographic North Pole is fixed. It's where Earth's rotational axis meets the surface. The magnetic North Pole is different. It's where magnetic field lines dip straight down into the ground, and that point actually moves. It's been drifting since explorer James Clark Ross discovered it in 1831. But over the past few decades, that drift has taken on a genuinely new pace. Since the 1990s, its speed jumped from a leisurely 15 km per year to as much as 55 kilometers a year. Geophysicist William Brown of the British Geological Survey has described the pole's recent behavior as something researchers have simply never observed before. Then it got stranger. After years of accelerating toward Siberia, the pole's movement suddenly slowed again, dropping from around 55 kilometers a year back to roughly 40, which Brown has called the largest deceleration ever recorded for it. Speed up dramatically, then slow down dramatically, all while still moving faster than the historical average. Why does this matter beyond compass accuracy? Earth's magnetic field is a massive shield against cosmic radiation and solar wind. The pole's movement gives scientists real clues about what's happening 2,900 kilometers down in the outer core, a moving sphere of molten iron and nickel. That motion, combined with Earth's rotation, generates electric currents, and those currents generate the magnetic field. Scientists call this the geodynamo. The honest answer for why the pole is behaving this way right now is scientists don't fully know. There are competing theories, changes in the outer core's molten iron flow, or changes tied to the field's overall strength. Geophysicist Kieran Beggan, also of the British Geological Survey, has explained that the field's total strength has been declining for centuries, but unevenly, weakening over Canada while strengthening around Siberia, which is part of what's been pulling the pole in that direction. Over the past 200 years, Earth's magnetic field has lost roughly 9% of its overall strength. That doesn't sound dramatic, but it genuinely concerns geophysicists as an ongoing trend. Some have speculated this could be an early sign of a geomagnetic reversal, where the north and south magnetic poles actually swap. Before you panic, these reversals are a completely normal part of Earth's geological history, happening on average every few 100,000 years. The last one happened roughly 780,000 years ago, meaning we're arguably overdue by that average. But a reversal wouldn't be a single sudden day. It would unfold over thousands of years, and there's no strong reason to expect one in any of our lifetimes. Here's a real practical consequence, though. Scientists have to regularly update the world magnetic model, which underpins navigation for everything from smartphones to military equipment. It's normally updated every 5 years, but in 2019, an emergency update became necessary because the pole was moving fast enough that the old model had become measurably inaccurate. Brown has explained that the longer you wait to update it, the bigger the resulting error. To put that in perspective, using an outdated model to navigate a straight line, roughly 8,500 kilometers, from South Africa to the UK could leave you about 150 kilometers off target by the end of the trip. That's the difference between landing in London and landing in the North Sea. Now here's the part worth closing on directly, because I know exactly what a chunk of you are already thinking. Does any of this connect to earthquakes or volcanic activity? Based on the actual published science, no credible evidence links Earth's magnetic field behavior to current earthquake or volcanic activity. Earthquakes come from tectonic stress building in the crust. The magnetic field comes from circulation in the molten outer core. Two entirely separate processes, at completely different depths. The magnetic field also changes relatively slowly, while earthquakes and eruptions are sudden threshold events. If there were a real driving link, you'd expect a measurable correlation in the data, and no study has ever shown one. Throughout history, major quakes and eruptions have happened regardless of what the magnetic field was doing at the time. The ground shakes because of ordinary tectonic forces, not a wandering pole. So here's the real scorecard. The Gulf Stream story quietly touches AMOC, and AMOC has a loose, uncertain climate change thread. The jet stream and the Arctic polar vortex both share El Niño as a common driver. That's a genuine direct link. The Antarctic vortex has its own separate, still unproven possible link to a 2022 volcanic eruption. And the magnetic pole stands completely alone, driven by processes 2,900, 1,600 now counterkilometer underground that have nothing to do with the other three. 4 systems, one overlapping moment in time, but not one unified cause. If you guessed the jet stream and polar vortex earlier, congratulations. That's the one genuinely direct connection in this whole story. And honestly, That's the more fascinating takeaway. Not that Earth is sending one coordinated warning, but that several genuinely independent, enormously complex systems are all quietly reminding us how much we still don't fully understand about the planet we live on. If this kind of here's what's actually true versus what's just a good headline breakdown is your thing, subscribe, and let me know in the comments which of these four you want a full deep dive on next.